Next we have number of onto homomorphisms from Z6 to Z6. Okay, so clearly GCD of 6 comma 6 is what? 6. Hence number of homomorphisms exists is 6. Of the forms T of x equals to 0x, second one is T of x equals to 1x, next one is 2x, next one is 3x, 4x, 5x. Okay, so these are the possible homomorphisms. Now we need to check out which one is onto. So for onto we just need to check whether the GCD of that 0 and 6 is 1 or not. GCD of this is itself. So this is not onto. Here GCD of 1 comma 6 is 1, it is onto. GCD of 2 comma 6 is 2, it is not onto. GCD of 3 comma 6 is 3, it is not onto. 4 comma 6 is 2, it is not onto. 5 comma 6 GCD is 1. Hence the onto homomorphisms are only T of x equals to 1x and T of x equals to 5x. So from here we can just find, like if we are having a mapping, basically it is a mapping from Zm to Zn, and we are interested to find the number of onto homomorphism. Firstly we know that number of homomorphisms equals to GCD of m comma n, and number of onto homomorphisms will be given by phi of n. Phi n, basically we know that all those numbers which make GCD with n is 1. So in this case, like we have taken Z6 to Z6. Yes, here n is 6, so we find out the value of phi 6, and phi 6 is nothing, just what? Phi 6 is basically phi of 2 into 3, that is equals to phi of 1 into phi of 3, that is equals to, sorry, phi of 2. Phi of 2 is 1 and phi of 3 is 2, that is equals to 2. So here we get number of onto homomorphisms as 2. Okay, so there is a one more condition. If we are having like Zm and Zn and we are interested to find onto homomorphism, there is a condition that n divides m. If n doesn't divide m, we can't think of onto homomorphisms. Okay, for example, I am interested to find, okay, this is the mapping and I am interested to find the number of onto homomorphisms. So clearly 6 doesn't divide 15, hence there is no onto homomorphism possible. Okay, that is a trick.